Hey guys, thought I'd go over the complete process of machining this case for the high-speed camera. I'm sure to learn a lot of things along the way. This is quite a complex machining job. I guess we'll start right from the beginning, cutting the stock. Cutting quite nicely. This is an old 12x7 bandsaw I picked up used. Needed a bit of work, but it seems to be running pretty nicely now. Probably shouldn't get the camera too near to this. I've got the stock in the machine. It's zeroed to the top left corner as it should be in the program. I've got all the tools, tool height set now, so we should be pretty much ready to go. I'm just going to give the program a quick test run, just cutting air just to make sure it's working right, and then we'll actually make some chips. Okay, here we go. Should do a facing operation. Yep, that seems right. Just hold the tool in there. Yep, that height seems about right. To reduce some of the mess, I've come up with this chip and coolant catcher just out of Coroplast. This should contain a lot of the spray and the chips that go flying everywhere, so hopefully it won't make the room so messy. It's not so much the chips I'm worried about, it's mainly the coolant, because it'll get over everywhere and make the floor all oily. Okay. Probably get the coolant on. Spraying quite a bit. Coolant catcher's working pretty well. Chips are still flying all over the top of the thing. sorry about that. It is difficult to get in here with this, oops, getting a coolant drip there. Yeah, we're dripping quite a bit of coolant there. I better solve that. Okay, what's going on? It's piling, chips are blocking the coolant return path. Okay, let's try that again. Okay, that operation's done. Now it's going to do the roughing of the inside of the case. It's a bit weird here. I think I must have set up the program a bit wrong because the corners are not rounded. They're sort of linear, but the finish is excellent otherwise. Not it doesn't end the game, but that's a bit annoying. I'll have to check that program. Okay, should be slightly better angle now. But also the coolant spray is not going to get on the camera. Okay, now it's getting into eye machining, which is a little bit... I have to get used to this. It makes me nervous when I can feel the ground shaking. I'm going to have to change to air blast coolant. This is not clearing the chips out properly. You said there are 2 hours. Yeah, that was definitely not that long. Yeah, I should probably turn the cutting oil flow up. That's a bit much.
Are you recording?
Yep. Okay, now it's going to take its cut. Look at those chips fly. Same thing with my camera. Yeah, this old machine is a bit too old for this modern program. It's running quite slowly, but yeah, it's getting the job done. That's where the controller is a bit slow. We do about 5 lines of code per second.
So cool you managed to make it work.
Yes. It was really fussy. They fixed a lot of little things in it. The Z-axis is still a bit wonky and it might shut down due to that. It's always nerve-wracking seeing it move so fast, so close to the material. I always put my hand near the button, near the speed control and stop it if it does something wrong. Turn the air down a little bit now. The tool paths they produce are quite beautiful almost.
Yeah, really.
Optimized
cutting pad.
So this is going to do everything except cap the hole.
Maybe the drill, you put drills in it, yeah. Oh, I see. That's pretty cool.
I think that's inside that block somewhere.
Well, that's what it's
Yeah, that's what it's making, yeah.
Oh, happy up here.
Good.
That direction?
Yeah. Yeah, with the thing on the right, the battery bulb.
So this is what you're making.
This is what I'm making, yeah. A lot of little steps.
I can't see it.
It comes in
Yeah.
It's going to be interesting when it cuts into that pocket full of fluid. Yeah. Yeah. Modern machine could be 10 times faster than this. No, it's going to cut it off. I don't know why the program chose to do it like this, but it's going to cut it off later. Oh, it left a little sliver.
There.
Yeah.
Not nice enough.
No. Or it's like stretching the metal into foil. There we go.
Go that way.
Yeah. Gets around. I should actually probably vacuum.
Yeah, I was gonna say.
Yeah. Okay, so we're don't have enough coolant getting in there because you can see there's chips getting stuck in there. So we're gonna have to get better coolant, better lubrication. So a bit of WD-40 helps. Okay, operation's done. Yeah, that's annoyingly slow.
I just think it's cool that it's doing it.
Yes, it's actually doing something.
That's precise right there.
I don't know why it's doing it the way it's doing it, but it is.
It's like my embroidery machine. Whenever I see it embroidering, I'm like, what are you doing? What are you doing that for?
I spent like a week learning to do the programming for this because it was so many little fiddly things, and it was doing much stupider things initially. At least now it's doing something reasonable.
This is the barrel, right?
This is where the lens goes.
Oh, right. That's going to be square eventually, right?
Yeah. Okay, looks like we have a problem here. It attempted to sort of wrap it around this corner here, and the end mill struck this because of the it tried to go, basically tried to go around like this, tried to go around this corner, and due to the servo lag, which is sort of the lag between where the servos are and where they're commanded to be, it struck this protruding part and broke the end mill. So I'm going to have to adjust the speed of the rapids or change the program in some way so it doesn't do that. It also did that a little bit over here in this back corner, but the end mill was strong enough that it didn't actually break. Yeah, so this eye machining does not produce a very good toolpath for this particular operation. It's doing it's being way too conservative. It's generating a toolpath as if it was cutting for almost the full depth of the end mill, while in fact it's only it could move much faster. Anyway, I'm gonna have to. I only have one of these end mills. I should have ordered more. I'm gonna have to get another and then continue later. Okay, I found another end mill actually. It was in my box of cheap Chinese end mills, so we'll see how this works, but at least we can continue right now. Okay, that's all set up back again. I've zeroed it off the corners of the part, and I checked in the CAD program what the offsets were to the zero that I'd done before off the block. I've offset it from that, so that's all set up again. So this should, crossing our fingers, be able to continue from where we were. I've also completely redone the cam for this operation with this end mill. So the other old one using eye machining was about 22,000 lines of code. This new one, which I've just done using conventional machining, is only about 1,500 lines, so it should be way more efficient. Seems to be operating much nicer. A lot less line to decode, yeah. Okay, that worked pretty well, except for one, at the very beginning, the first plunge, where it plunged in the Z-axis, was quite fast. It seemed like it was almost at the rapid rate. I'll have to go check the program. This operation will clean out all of the curved contours in the battery compartment. This is going to take a relatively long time. I think it's about half an hour to do this. Yeah, right now it's just cutting parts that were already cut in an earlier operation. I could have optimized the program to remove this. Now it's actually starting to take some cuts. I'm just taking some really small cuts, yeah. I'm glad it's not shattering badly against the very thin walls of this piece. So I'm quite surprised the earlier operation didn't shatter badly either. Since I only have one chuck for multiple different drilling operations, what I've done is just use one chuck with, I just put a little something on the drill to hold it at a certain position, so I can do the individual zero each different drill at the same position in one chuck, and then I just have to change, instead of changing chucks, just change the drill bits in the chuck. And this one is long enough that I can just push it all the way up into the drill chuck, and it will just hit the stop, so I don't have to actually put any sort of reference piece on it. Works quite well if you don't want to have to buy a whole bunch of chucks. And we are done. That looks really nice. Let's clean all the coolant off of it, especially the milling of the battery chamber. That's really smooth. Yeah, that's nice. Seems quite precise. Edges are pretty sharp. Yeah. Bit of a problem here where that the servo lag caused the cutter to take a shortcut. So I'll have to change the program, but yeah, not bad. Now that looks really nice once it's cleaned up. A few little burrs on the edges I gotta get off, but that is really nice. Yeah. And the 3D printed housing seems to fit pretty much perfectly. Nice. There's a bit here that's not fully machined yet, but yeah, everything that can be pushed down is perfect.